I'm going to review with you how to make a graph correctly. And then we're going to talk about how to linearize the graphs, because in order to do any of the calculations in this lab, you're going to need a linear graph, and the data you're going to get is not linear. So we're going to have to talk about how to do that. So let me open this up. Olivia, you've turned it in, or not turned it in, but attached it. Yep, there it is. I make this a lot smaller. Okay, so file. It's not going to let me make a copy. All right, so here's what I'm going to do. I'm just going to copy. It's not showing it. It's on your, there you are. Okay, you're all set. You're welcome. All right, where am I? I'm here. All right, so this is the data that Olivia's group collected. All right, so a couple of things. And let me just make this full screen so it's bigger. We have some data that's out of order. Okay, it's printed one? No, unsecurely. I was just in there. So you're going to sit with your group and take out your Chromebook, please. There you are. Okay. So a couple of things with this. We have things backwards. We need to flip-flop the times and the displacements. Okay, and we have to put .0 on here too. Okay, so let's do that. So I'm not going to edit yours. You're going to edit yours. I'm going to edit. This is a blank copy. I just copied and pasted your data. Okay, so the way I'm going to do this is by this. I'm going to take this column. I'm going to copy it, and I'm going to paste it here. There it is. Control C, Control V. And then I am going to delete this column because I don't want that. Whoops, apparently not. Did you put formulas in yours? Okay, these times are not correct. I'm going to tell you that right now. Let's go over how you get the times. In the lab handout, folks, it told you that the machine was putting down a certain number of dots every second onto your timer tape. What did it tell you? How many dots were being put down onto your timer tape every second? 60. So 60 dots is 1 second exactly. Now, how many dots were you supposed to count off between the dots you labeled? Every 3. So if 60 dots is 1 second, what are 3 dots equal to in seconds? So 3 dots over 1, 60 dots is 1 second. So how much time elapses with 3 dots? Come on, work it out. Tell me. How much time for every 3 dots? Okay, 0.05 seconds for every 3. Okay, so these times should be nice and exact. So when we come back into this, we got to change these times. So I am just going to delete this column. And I'm going to start putting in. first thing I'm going to do is I'm going to insert a row, because we have to start from dot 0, because you're always measuring from dot 0. How much time between dot 0 and the 0? Okay, now all of our times need to go to the 100th of a second. Here's how we make that happen. Did you see I typed in 0.00? And then my spreadsheet just dropped the 0.00. That's because the formatting of the cells is not set up to go to the hundredths place. Here's how we fix that. If I select column B and all the data that's in there, you see you have these increase and decrease decimal place numbers. I'm going to click this increase one. That gets it all to the tenths. I go one more, and now it's all out to the hundredths. That way, all the data has the correct precision for the times. Now, time 1 needs to be the value here plus 0.05 seconds. So I'm just going to say this equals this number plus 0.05. And then what I'm going to do is say that this one equals that plus 0.05. Now I've created a recurring formula, which means I should be able to take this and let's see if I drag it down, if it will copy that formula. It sure does. So I don't have to keep recopying it all the way down. What I did to copy it all the way down, folks, is I went to the bottom right corner of the data. And you see that my cursor just changed to a plus sign. When it changes to a plus sign and you drag down, that's what's called autofill. Use the formulas in the cells above it to continue that formula all the way down, and it will just keep doing the math behind the scenes for you. All right, so your data went up to 1 second, which is fine. Gentlemen, are we all doing this? So your data is getting set up correctly. So you have your dots in the first column, your dot numbers. These are the ones that you labeled. You labeled every 3. Then you have your times for every 3. And they increment by 0.05 seconds each time. Now the next column has, length, this should be displacement, right? This is all displacements. And you don't have to say from 0, that's assumed. Displacements in centimeters, that's fine. How far is the 0 dot from the 0 dot? 0. So I'm going to type 0 again, and I have the same issue with the formatting. So I'm going to increase the number of decimal places to 2, and I want to make sure that all of the data is measured out to the 100th of a centimeter. And that looks like it is. So that's all fine. If yours is not, you need to change the formatting of your cells so they all go to the 100th of a centimeter. Okay? Now let's review how we're going to make a graph of the displacement versus the time. So you can all do this with your data. You're going to select the time and displacement column headings, and then you're going to arrow down as you hold down your shift key to select that. We don't use the dot numbers in our graph. So my data is going from, if I look in the name box here where it indicates what cells are highlighted, the data is going from B1 to C22. I'm now going to go to the insert menu and select chart. Charts are graphs in Google Sheets. Now I'm going to maximize this window so it looks a little easier to see. This graph looks pretty darn good, except we need to edit it. And I'm going to move this graph up so it's next to the data in the table. The first problem that you should notice is that the title of the graph is incorrect. We never put units in the title of a graph, which means we have to come into our title and edit it to delete those units. So it is just displacement versus time. This looks pretty good. It's a scatter chart with the displacement in centimeters versus the time in seconds. You need to add the best fit trend line to this. All of our trend lines in this course are either linear or power series type. That's it. Linear or power series, nothing else. What did I just say? What 2 types? Okay, very good. I want to make sure you heard that, because if you ever select another type, it's wrong. How do I figure that out? Because I'm going to look at the equation of your graph. You're going to double click on your graph. This is all under the series option. We're going to scroll down to where it indicates that you can include a trend line. Google Sheets default is always linear. It's trying to put a line on the graph. We don't want linear. We want what type? Power series is for every curve you're going to have. You do need to then add the label for the equation. So when I click off of it, that is the equation for my graph. Okay, and that's it. This is telling me that the displacement in centimeters is equal to 85.6 times the time raised to the 1.51 power. Okay, good. Just want to see what the maximum was. Yeah, you got to that here. Okay, so now that is not the final graph you're going to need. What we have to learn how to do is linearize this so that way we can do some math with it. We need to create a line graph from this. And here's what we're now going to do. You all have a new Google Sheet, which was pushed out to you on how to linearize graphs, a practice assignment. So I would like you all to go to that, and then I'll show you what we're going to do. Where am I? This is not in Lab 4. I need to come back in here, go into your Google Classroom, and you'll see it's under Lab Resources, in fact, because you're going to do this and keep this. It says Graph Linearization Practice. Open up the Google Sheet. We are going to practice how to linearize different types of graphs, and I'll show you how it's done. Okay, is everybody with this Google Sheet with me? Let me make a copy so I don't edit my master. This is 2025. All right, so here's what we're going to do. Are you all with me? Okay, this is going to take practice, but I can guarantee you one of the 4 constructed response problems on your AP exam is doing this. But you're going to do it by hand, not with a Google Sheet, which means most of the graphs we make in this course for labs are going to have to be linearized. I have to get you to learn how to do that because I know that is one of the things you have to do on your AP exam. And I want to make sure those points, you can bank them, because the other stuff, they're derivations of I don't know what. This, everybody has to be able to do, okay? Every AP Physics exam for every AP Physics course that's offered has to be able to do this. Here's what you're going to do. You're going to start by just making a graph. So is everybody in example 1? We're going to make a graph that goes with position and time data that's here. So select the data. You're all doing this individually. This is not a group activity. This is an individual activity because you're not going to take the AP exam as a group. You are taking your own individual test, which means each of you needs to know how to do this by yourself. So select the data. Do not select where it says table 1-1. That's too big. Okay. Go to your insert, say chart. Okay, we get this graph, which looks lovely. However, we have to modify it. What's wrong with the title of the graph? It has units. And in fact, because we're going to have multiple graphs, we're going to modify the title even more. Do you see how this data table that we made the graph from is titled Table 1-1? We're going to call this Graph 1-1, which is a position time graph. So I know this graph was created from that data table. You follow? Because whenever you have to linearize a graph in an experiment, you have to show every data table that you created and every graph in the process to linearize. This one is going to have 2 data tables and 2 graphs. So this is the first graph that goes with our first example. I am going to make this graph a little smaller just so that way it fits on my screen. You can probably keep yours the same size if you want. I just want to get it on the screen so you can all see it together. Okay, You have to add the trend line for this. Is this going to be a line or a curve? It's definitely a curve. So let's double click. We go to the series option, head down to trend line. And instead of selecting linear, you're going to select power series. I'm going to close it out. I actually do not need the equation for this because the equation is immaterial. I don't care about it. This graph is no good to me right now, other than looking at the shape of that graph. If we go back into our Google Classroom, there is a document that we're going to use as a resource right above the graph linearization practice assignment. You see it's graphical summary sheet. Go ahead and open up this PDF document. When I look at this document, it tells me that if I have this graph shape, I'm done. I want to try to get to a line. Notice that the graph shape I'm looking at is second from the bottom. It's this one here. Notice that the third column of this chart tells you, do you see it says modification required to linearize the graph? This is what it's telling you you're going to have to graph. If I come down based on this shape, we have to graph whatever's on the y-axis versus whatever is on the x-axis squared. Okay? So if I go back into my Google Sheet, it means my second data table is going to be whatever's on the x or whatever's on the y, which is position. I'm going to keep that. But then I have to square all my times and plot it against the square of time. So what I'm going to do, make this a little smaller so it fits on my screen better. I'm going to create a second data table here. This will be not table 1-1, but table 1-2. Now, what I'm going to do is just start by copying over what I had in table 1. Copy it and paste it right below table 1-2. You all with me? So far, so good? Okay. The problem is that in order to linearize this, I don't want the times. What do I want? On the x-axis to make the line, the graphical summary sheet said to plot it versus the time squared. So we're going to change this label to time squared. That means the units is not seconds, it's seconds squared. Caret 2. And actually, I can make that time caret 2 as well. That's probably a little easier. Okay. Now, you're not going to, in your head, square all those numbers. You're not going to square them yourself. Instead, what you're going to do is you're going to tell it to go back to the data in the first table. So I'm clicking my first cell. Do you see what I just did? I said it equals, and then I clicked cell A3. I wanted to square that number. So I'm going to put after the A3, caret 2. Excel knows that the caret means square it. Hit enter. I'm now going to click on that 0 value, go to the bottom right so my cursor changes to the plus sign so I can autofill that formula down the table until I get to the 10-second box, autofill it down. And you'll see that it automatically took all the numbers in the first table and now squared them here. Are you with me? Okay, here's what we do. Now you're going to create the graph that goes with this, position and time squared. So select that data, go to Insert, Chart. There's the graph. I have to modify the title. So this is now Graph 1-2, which is position versus time squared. Now this graph should be linear. Does it look pretty linear to you? According to the graphical summary sheet, it should have been linear with that modification. So we go to series, we tell it to add the trend line. Now, because it is linear, you have to do 2 additional things. You need 2 additional things for this graph. Because it is linear, for the label, please say use equation. And Every line graph you create needs what's called an R squared on it. R squared, your linear regression, I think you learn about this when you do algebra 1. You do all the stats on your graphing calculator. The R squared, your linear regression, tells you how well the data fits the line. It does not apply to curves. It applies to lines. That's why we call it linear regression. If you put an R squared on a curve, does that make any sense? Because it's not linear, okay? The best thing you can get is a value of 1. That means every data point you plotted was on the line. Perfect. Are you ever going to get a perfect one? Rarely. But we do here because I just made up numbers. This is all made up numbers, so yeah, they're perfect. This is what we need to now do analysis. And if you could, grab your notebook. I'm going to show you what you do with this equation that Google Sheets just gave you for this graph. Grab your notebook. I'm going to move this over. I'm going to shift to my document camera to show you what you do with this. And I'm just going to write down what we saw. Google Sheets gave us an equation that was y equals 1 times x. And this was position in meters and time squared. All right, so this was the graph. And on the graph, we had the position in meters and time squared in seconds squared. We got this line. And that was the equation we got for it. Okay, now Google Sheets doesn't put the y equals. You add that. We have to change that. The y is the name of the variable that's on the y-axis. So we're going to change that to position, which we know in AP Physics, we use an x for position. 1 is the slope of this. So the units would be 1 meter per second squared. And x is what was plotted on the x-axis, which is time squared. So our equation for this function is x equals 1 meter per second squared times t squared. From this, you can do all kinds of calculus. Okay? You can do all kinds of calculus with that. You can figure out what the velocity is. How would you find the velocity of that? Now you would take the derivative because you needed the equation of the line to do that. So to get your velocity, you would just take the derivative of that. If I wanted the acceleration, what would you do? Take the derivative of that to give you the acceleration equation. Okay? The graph that you create in lab 4 is a lot like the graph we just looked at. Has the same shape. So to linearize it, what are you going to have to do? Square the times and plot it. Get your equation. The units won't be the same though, because we didn't measure in meters, we measured in centimeters. Okay, yeah, you measured in centimeters, not in meters. Okay, let's go back. Let's look at how to linearize some other ones. Okay. So let's look at example 2. Your goal is to create a linear graph every time. So if we look at example 2, first thing you got to do is create a graph that goes with this data table. Figure out what the heck shape it is. Insert chart. There it is. So the graph title, this would be graph 2-1. This is position versus time. This is not a line. It's another curve, isn't it? The curve, when I add the trend line for it under series, since it's a curve, I have to add the trend line that is a what type? Power series. It's not such a great fit. Really? Polynomial is better. Not exponential. All right. I'm going to change what I said a minute ago. I'm allowed to change my mind. In Regents, we're only going to get power. AP, your data is going to be funky. So power and polynomial are okay. All right. This one is polynomial. We don't need the equation on it, though. We just need the shape of that graph to help us figure out what we have to do to linearize it to come up with our second data table. So where am I going to look to figure out what I have to do to linearize this? That graphical summary sheet. So let's go back, look at the graphical summary sheet, which I think we have opened, right? Here it is. This is the graph right here, right? This one right here. The last one. That's it, right? That's the shape we have. Look at what it says you need to plot. Y squared versus X. Okay, so we're going to go back to that Google Sheet. And that means we're going to create table 2-2. And what we're going to do is we're just going to copy table 1 to begin with. Yeah. Come back. We're going to paste it. But then I got to square my position. So I'm going to change my column heading to position squared. So this would be in meters squared. And now to get these positions squared, I'm going to say equals. I'm going to put the formula. Where do I get the data from? Table 2-1. And then I'm going to put the caret 2 after it. So it takes that number and squares it. And then I can autofill that data all the way down this table, go to the bottom right corner of the cell, changes to a plus, and then drag down. There we are. There are all those positions squared and meters squared. So far, so good? Yeah? Okay. So now that I have this, I'm going to create a graph that goes with table 2-2. So insert, chart. There it is. Is there a title on this one? Yes. So let's change the title. This will be graph 2-2, position squared, get rid of the units versus time. And let's see, if I make this a little smaller. That's not in the room, I don't think. I think it's out in the hall. At least it better be. I'd hate to have to call a principal down here. They'd be like, what the heck? This is AP. You guys can't follow rules? You all broke the law. All right, so let's head down. This is not that great of a linear curve, but we're going to make it linear. All right, so double click, series, add the trend line. Needs to be linear. The label should be use equation, and because it's linear, we're going to show the R squared. So when I look at this, looks pretty much like that. Look at the R squared. It's close to 1, but it's not 1. And there is my equation. Yes, Maddie? The only thing I can say is reboot. Sorry, I don't know what to do. Control-Alt-Delete is usually, or power key, just press your power key, hold it down. You got it? Okay. Everybody okay with number 2? Yes.
Are we putting the R squared on like all of your graphs from now on?
Correct. Yeah. And that is one of the things you look at to determine how accurate your data is. Okay. The closer it is to a perfect one, the better. Maybe not as accurate. That's incorrect. How precise your data is. How exact. Okay. Can we try example 3? Okay. So start by making your first graph. I am recording all of this, so that way if you need to go back and look at this at some point in the future, you can. Okay, so this title has to be graph 3-1. This one has an additional step on modifying the graph. Every graph you make should have a 0, 0 on the bottom left corner of the graph. When I look at this graph and I look at the bottom left corner of the data in the graph, I don't see a 0 on the x-axis. You need to put one there. And you don't do that by modifying the data table. Let me show you how you get a 0 on the x-axis of your graph if it's not there. So pay attention so you can do this yourself in the future. You double click on the graph, you go to horizontal axis. And there's an option for a minimum value to display on the graph. That is going to be 0. As soon as you hit 0, boom, there it is. And now you get your vertical axis, which you want. Okay. We have to add our trend line to this, which we're going to try Power Series first. So that's always a better choice if it will fit it. It's definitely not linear. Yeah, Power Series fits it beautifully. I don't need the equation for it because we're not going to do anything with that equation. So this is graph 3-1. That is position versus time. Some students ask me, what the heck is this vertical line over here? This is a hyperbola. Hyperbolas are asymptotic towards some value. That's the asymptote. That if this graph were to continue indefinitely going to the left, it would approach that numerical value right there. That's the asymptote. Google Sheets is showing you the asymptote that it approaches. But we're not going to do anything with that graph. We just need it so we can figure out how are we going to linearize this. So if we go back to our Google Classroom and we look at the graphs that are here, notice that the graph we just created was this one, which means to linearize it, you have to graph y versus x to the -1 power. So let's come back in to our sheet. We're going to copy this table. This is going to be table 3.2. We need y versus x to the -1 power, which means that time needs to be the inverse. So that's the same as 1 over time. 1 over time, which means the units would be 1 over seconds. It's like frequency, right? Frequency is 1 over time. Now, how do we get the 1 over? We say equals, we go back to the first data point, and we're going to put in front of that A3, we're going to put a 1. So 1 over A3. We hit enter. And now I can autofill that. So if I autofill it properly, the next value should be 1 over 2, which is a half. And so on and so forth. Now notice it's giving me all kinds of wacky decimals. You're just going to show it to 1 decimal. So we're going to change all of these, adjust the formatting, and we're going to adjust them so they all show 1 decimal. Oh, maybe not 1, maybe 2. 2 is better. That way we can see a difference. We're now going to take this data and create graph 3.2. Insert chart. This is because my screen is so big, it's hard to get it so you can see what I'm doing. I need this slider bar. There we go. So this is graph 3-2, position versus 1 over time. And now when I look at it, does it look linear? Yeah, that looks pretty linear, but again, I don't have a 0 on the horizontal, so I'm going to adjust that. The horizontal axis, the minimum value needs to be 0. There we go. And now I can see that's going to look pretty linear. So I can now add my trend line to this under the series submenu. Trend line should be linear. What 2 things do I need to add? The equation and the r squared. Notice now my r squared is 1. Beautiful. So let me shrink this graph down so I can see it and it doesn't cover up the data table. off to the side. And can I see the whole thing there? Yeah. Almost. Okay. How we doing with example 3? We good? Okay, let's go to example 4. This one's the trickiest. This one will require 2 steps to get it to be linear, not 1. On each of these, we just did 1 additional step to make it linear. This one will need 2. So we're going to start by making our graph that goes with table 4-1. It's out in the hall. It's the teachers across the hall. So we're going to modify this graph. Again, fix the title first. So this is graph 4-1, position versus time. We have to modify the graph as well. So that way we have a horizontal value of 0 on the bottom left. So set the minimum value on the X to 0. I can now add the trend line to this, which is under the series submenu. Trend line, not linear for sure. What am I going to try next? Power series, and that fits it beautifully. All right, so I'm going to move this over. I'm going to shrink it up. Okay, now I got to make my next graph, which according to what we did previously is going to be table 4-2. And this needs to be the y versus 1 over x. So this needs to be 1 over time. So that means the units would be 1 over seconds. And then I'm going to set it so it equals 1 over A3. I can then take that and drag it down. There we go. I'm going to adjust the decimals to 2 like I did previously. I'm going to try graphing this one. And you're going to see this is not linear, which means we have to do this again. So this is graph 4-2. All right, so here's what I want you to do. Tomorrow, we're going to go through the chapter 3 presentation, but before I start that, we're going to finish this. And then we'll finish our discussion of what you're going to do to finish lab 4. Okay, with a linear graph. If you want to try to linearize this one, be my guest. But your goal for tomorrow is to read chapter 3 and take notes, okay? All right, folks, have a wonderful day. I will see you tomorrow.